The ability to image the beauty of the nighttime sky is something that few people take for granted in this hobby. The equipment, software, and processing power that we have in our own homes allow us to bring out incredibly faint details of distant objects that are hundreds to sometimes millions of light years away from our own backyard. In today's video, I'm going to walk you through my advanced workflow in PixInsight, specifically focusing on how to generate star and background masks to focus the processing power of this software on the faint details of our deep sky objects. If you enjoy this video, please like it and subscribe to this channel. But most importantly, let me know how you're using PixInsight and any questions you may have in the comment section below. Now let's jump right into PixInsight and take a look at where we are in our processing of the beautiful heart and soul nebulas. We're going to jump right into my workflow about halfway through processing the heart and soul nebulas, because this is where we're really going to start to get into some of the more advanced parts of PixInsight to bring out some fine details of this deep sky object. So far, to get to our starting point, I've stacked my light, flat, dark, and bias frames in Deep Sky Stacker, taken that final stacked file into PixInsight, and removed the light pollution, calibrated colors, stretched the image, and done some noise reduction. Each of these important early steps are covered in a previous video, and I'll be sure to leave a link to that video in the description below. Out of all the things that we're going to be talking about in today's video, I think one of the most important and difficult to get is the star mask. It's really going to be the base point of a lot of what we're going to be doing with our processing. So let's start with it right now to help you figure out how to get the best star mask that you can to protect the stars of space to allow us to process everything else in it. So let's go up here to Process. We'll go down to Mask Generation, and we'll click on Star Mask. Now, the default settings that we have here are typically a good starting point. The main things that you're going to want to focus on are scale, large scale, and smoothness. Those are the three that I tweak and change the most when I use this almost every time I'm processing my deep sky astrophotography. Let's begin with scale. Scale is going to involve pretty much the size of the stars that are going to be masked. So everything from the smallest stars that we have here to, in this image, some of the larger and brighter ones that we see right here. Let's begin by moving this down to 3. I don't think this is what we're going to use, but this will help to show us exactly what scale does with this. Let's go down here and click on Apply. We have our first sample here of a star mask. We're going to go over here, drag it below there. We see through this being highlighted that it's activated. So let's show it and let's invert it. So whenever you're working with a mask in PixInsight, anything that is red is not going to be touched by your processing. So what we want to look at here are what stars are or are not covered with this inverted mask. And we can see here we've got the small stars, the more dim ones covered, but our larger ones and brighter ones are not. So that tells us that the scale at being 3 is not what we're going to want. Let's go back up here and make sure we turn that mask off. Just reset all those features. Let's take the scale up now from 3. Let's take it back up to 5, where it was, I think, as a default when we opened up the program. Can tell just from seeing this right here that we have more stars covered in it. Let's go back up here to show and to invert. Okay, this is an improvement. So we now have some of these larger, brighter stars covered, but still not fully, especially if we get into some of the brightest ones that we have in here down in kind of the core of the Heart Nebula in particular. Now, the key for the scale feature is to increase it enough to where it covers your larger, brighter stars, but not to the point where it starts to cover the large-scale nebulosity that we have here. I do not want this mask touching any part of the nebulosity of the Heart and Soul Nebula. Now that can be hard to see when we have a dense star field like this, but I think we can maybe take it a step higher to cover these brighter, larger stars a little better. So let's take this up to 6, and let's apply that. Take this over here. Click show, click invert, and that's much better. Now we completely have our small and large, our dim and bright stars being covered. You even see more of it here at the core of the Heart Nebula. And from what I can see, we do not have any of the nebulosity being covered in the Heart and Soul Nebula. If I do Control K, that'll kind of turn it on and off. To my eye, I'm only seeing the stars in red, which means the mask would only deal with the stars, which is what I want. Now, these stars are a little bloated in terms of their mask. It comes out pretty far around, especially these brighter stars and larger stars. So let's go down here to large scale. That's going to determine the size of the mask around the objects that it's covering. To show this, I don't think we would set it to 0, but let's set it to 0 right now just to show the principle of what this deals with. Let's apply this and see what we have. Yeah, definitely a difference from our last one. Click show, click apply. So it definitely did shrink it around the larger stars, but now we just have the brightest core of them being masked. And that's not what we want. We want the glow around it. We want it to cover the natural image of the stars. So my guess and what normally works for my imaging and equipment is that large scale being 1 is going to be the best try there. So let's run it at that. That is much better. We have a tighter mask around our larger, brighter stars, getting the core of them and a little bit of that glow around them, which is exactly what we want. I still think we could tighten up the image a little bit on medium and small stars. Now, I hardly ever adjust the small scale. I never adjust the compensation, but I do change the smoothness. So let's take this from 16, let's half it and go to 8. And let's see if that kind of tightens up the mask that we have around our small and medium-sized stars. This is looking promising. Go to show, go to invert. That is much, much better. We've got the scale set to 6, which is having our larger, brighter stars covered. Our large scale set to 1, which tightened the mask around those stars a little more. and changing the smoothness to 8 really kind of cleaned up the mask a little bit. This is much preferable to any of the ones that we saw before. So this is the one that we're going to go with. We're going to go with this final mask that we did. Let's go here and clean this up a little bit. Can get rid of some of these older ones that we ended up not using or keeping. And let's deactivate this for now and just kind of minimize and put it over here, because we will definitely be coming back to this later on. Now, another thing you're going to want to use often is called a background mask. And to create that, we're going to go up to Process, go to Mask Generation, and go to Range Selection. So if the point of the star mask was to have us not touch the stars when we use some of this post-processing, the background mask is going to try to help us mask the background of space, pretty much what's in between the stars, with the exception of the Soul and Heart Nebula, which we do want our processing to focus on to enhance and to bring out fine detail. So we're going to click on Real-Time Preview here. We're going to go up to Lower Limit. We're just going to start increasing this number. And we're going to try to find the best setting that we can that reveals our nebula but doesn't have that bleed into the background of space. Now, with the wide field lens that I'm using, we've got such a dense star field that this is difficult to do. But looking at it here, I think the best I can probably do for this today is going to be the lower limit at 0.24. We definitely have some stars coming through here, but for the most part, it's going to be focusing on the two types of nebula that we're going to want to be processing here today. Now I'm going to go over here and go to Smoothness. I'm going to take this to about 10, just to kind of smooth out the effect a little bit that we're going to be doing. I'm also going to click Invert, which is going to help me in a few minutes when I try to combine this with my star mask. Let's click Apply. And now we have our second mask of the day, where we have, for the most part, and we can bring it over here to take a look at it. When you invert it, we have the red blocking out the background of space, and we have the opening here where we want our processing to hit for the Heart and Soul Nebula. Now you do see this come into the Heart and Soul Nebula a little bit, but for the most part, this is actually darker background of space that we have kind of going into it. So when you kind of turn this with Control K on and off, you can see that, yeah, this actually is a dimmer portion of it that isn't being touched here, where we have the brighter portions of it still coming through. So let's minimize this and put it right over here. So now we have a star mask and a background mask. What in the world do we do with them? Let's get to that right now. So the next thing I'm going to do is try to enhance the contrast and the definition of the Heart and Soul Nebula. Try to make them pop a little more. Try to bring out a little more structural detail and core detail to them. I'm going to be using a program to do that called Local Histogram Equalization. Now if we click Preview right here, we can see that we have the entire image very overly processed. If you take it down here to 1, this is what it looks like without it. Take it up to 2. It just makes the whole thing just kind of explode with contrast. And that's not what we want. We want to focus this process on just the heart and soul nebula. Not on the background of space, not on the stars. That is where our masks come in to work. So let's just move this down here for now. Let's take our star mask and our background mask and figure out what we want to do with them. So if we mask the stars, that's great for what we're doing here, but we're still going to have the background of space being processed as well. But if we do the background mask, that's great, but then we've got the stars that are going to be really too sharp and they're going to pop too much. So the solution is to combine these two masks, to take our star mask and our background mask and make them into one. The way we're going to do that is by going to a process called pixel math. Now we're going to need to rename our star mask, mask 1. We're going to need to rename our background mask, mask 2. Let's clean this up a little bit and kind of get them out of the way. Now we're going to have to make a duplicate copy of our original picture here, because that's really what's going to be used to create this new combined mask of the stars in the background. So we're going to go into Pixel Math and we're going to type in max mask 1, comma, mask 2. This is going to take our star mask and our background mask and combine them. How it does it, I have no idea, but it does it and it works. And that's all I care about. So let's go over here and click apply. And there you go. Through the miracle of PixInsight, we have now combined our star and our background mask. Let's go over here and take a look at what this did. Click show, we'll click enable, and we'll click invert. We have the background of space masked in red, which means it will not be touched by this local histogram equalization process. And if you go down here and take a look at the Heart Nebula, we also have the stars masked in red as well. So we have the background masked and we have the stars masked. Let's keep that enabled, but let's turn that off right now and not exactly show that. So I'm going to go up here. I'm going to make a preview of the Soul Nebula. Let's go here and click real-time preview of that. And here we have the effects of local histogram equalization, which again is to try to bring out contrast to these nebulas. We take it here to 1. We really see just how the image was before. We adjust it up to 1.5, up to 2. We start to see the impacts of what this process does. Now this always comes down to artistic interpretation. What to your eye, with your imaging equipment, with your exposure time, looks the most natural to you. To me, this looks not natural, at the contrast being at 3. At the contrast being set at 1, I think it's a little too flat of an image. Taking it up to 1.5, again, the mask helping a great deal with only focusing on the core here of this nebula. There is a little bit going on with the stars here, but not nearly what it would be without the mask being applied. I think we can take it a little more than 1.5. Let's take it up to 1.7. Now that's a subtle difference, and it may not be visible through your screen on YouTube, but to my eye, looking at my screen right now, 1.7 to me is the sweet spot between looking like it did and having more depth and a little more pop, which is what I want from this process specifically. So let's go up here and get rid of our preview right now. And let's apply this to the entire image. That is a very nice improvement. If we go to before and after, again, there is a subtle difference to the stars, but the mask definitely helps. But the real change that we see is what the mask is allowing it to process, which is the core of the heart and soul nebula. We go down here to the heart, and we can see that difference, that added contrast, that added depth, really, to my eye, helps to bring it alive. So from this point, we're going to be looking at a fine-tune adjustment of the stars themselves. Let's go up here and let's turn off for right now this mask. We're done with that for right now. I've only started to do star reduction in the past few months, but I've found that it really helps to draw your eye to what you were imaging in the first place. It doesn't make the Heart and Soul Nebula brighter, but the fact that you are dimming the star field around it just helps it pop that much more to your eye. When you're gathering these photons, when you're doing your 30-second, 45-second, 1-2 minute exposures, you're also exposing these stars at that length as well. And that can lead to them being overexposed and kind of blown out, especially in a dense star field like this. So what I'm going to do is try to use a process called morphological transformation to dim the star field. Now to do that, we're going to want to use the star mask that we made earlier. Just the star mask, not the background mask, not the combination of both of them, just the good old-fashioned star mask that we started this video with today. We're going to go here, we're going to enable it, we're going to click Show. Now in this case, we are not going to invert it because I want it to have the red on the background of space and to only allow this process to be on and slightly around the stars. Because remember, what is red is not touched by the processing. So I want to focus this effect only on the stars, not on the background of space, not on the nebulosity that we're working with here. So we'll keep it enabled, but we'll get rid of it in terms of seeing it. Let's go to Process, and let's go down to Morphological Transformation. Now, I don't change anything in terms of the default settings of this. I really just base it off of how much I use it, and then I'll come down and adjust this amount later as well. But let's keep everything default right now. Now let's go and click to apply this to our image and see what happens. Just from that, especially if we zoom in, we see here the difference. We have the nebulosity not touched at all, the background of space not touched at all, but the brightness and size of the stars reduced. Now again, this is going to be your artistic choice. What looks natural to you? What do you want to get out of this image? I think this is a great improvement in focusing the attention on the heart and soul nebulas and not on the beautiful but dense star field around it. Now you can apply this all day long as many times as you want, and eventually you're going to get an image that looks unnatural. That just looks really bad at that point. But if we go back here a few times, we can see again what we're doing here. So let's click on it again one time. That's a good improvement. Let's go down here and have the impact of it be roughly half of what it was before. Let's try it one more time. That's, I think, where I'm going to keep it for my image. You may do it again, you may do it more, you may do it less, but to my eye, we still have the beautiful dense star field. We still have the brighter stars breaking through, but now our attention is a little more focused on the nebula that I was actually trying to image. Just to show again how it was and where it is now. And again, because of this star mask, we are only dealing with the stars, not with anything else. We can turn this off at this point. But that to me is a more natural looking image, and it is artistically what I was looking to get out of this shoot. So we're now going to get to some steps involving enhancing the color that we captured here of the Heart and Soul Nebula. To begin with this, we're going to go up to Process, and we're going to use a program called SCNR, because we're going to have this remove almost all of the green from this image. Now you can't see hardly any green at all. Green is not a color that shows up much at all in astronomy or astrophotography for whatever reason. But we're going to click to apply that. You will notice hardly any difference at all, but that's something I always like to do before I get to adjusting color and trying to bring out more saturation in the image. So that's an easy, simple step. Now to make the final adjustments to color, we're going to be going here and using a different technique than I have in previous videos. And it's a technique that a member of my local astronomy club showed me, and it's what I primarily go to now for adjusting color. To start with, we're going to extract the lightness and create a mask, which is as simple as coming right up and having one appear right here. So we're going to go here and we're going to apply this lightness mask. We're going to enable it. Then we're going to go up here to a process called LRGB combination. We're going to uncheck all of them except L. And then to give us an idea of what we're doing here, let's come down here and make a preview of the Heart Nebula. Let's take a look at what this is going to do. Now, if we keep it at default, it won't do much of anything. So let's go down here and let's adjust the saturation to 0.250. Let's apply this and see what happens. That's a pretty good improvement. If we press Control-Shift-Z, we can turn that on and off. And again, it may be subtle on your screen, but that's really helping to bring out some of the natural colors here. I think we can bring a little more out though in terms of saturation. Let's go to 0.1. Click Apply. That is beautiful. We've got the stars, we've got the Heart Nebula. The black background of space is staying that way because of the lightness mask that we applied. Now the question for each of these steps is always, how far do you take the process? To me, taking it down to something like 0.20 and applying it, it is really overkill on the saturation. I mean, that's a lot of color, but you're kind of blowing out your stars. That's just not a natural looking image to me. At the same time, when I had it at 0.25, it's a nice improvement, but it's maybe a little too subtle. Normally, for what I use this for, I normally have it around 0.08 to 0.10. That's my sweet spot, but it depends on the image, it depends on the exposure length, the object. But for this right here, again, pressing Control-Shift-Z, that's where I think I'm going to keep it. That's adding some good saturation without, in my opinion, making the image look a little too oversaturated. So let's click Apply for the entire image. That is a great improvement. Go to before, after, a subtle but nice pop to the image. Let's go up here to turn this lightness mask off. And now we're going to do just some final adjustments really of this image. Let's go up here to Process. Let's go to Histogram Transformation. Let's click on the right one here, which is just the heart and soul. We have here the information up on the screen, and let's click Preview. And let's see if we can maybe darken the background sky just a little bit. Now, you don't ever want your background of space to be too dark. I'm not going to bring this in too much, but maybe right around here would be a pretty good change. Yeah, I like how that looks. We still have the vast majority of our information showing up there. We did not clip too much at all of it. Well, we're about done with this image. There is one more thing I would encourage you to do. And that's to go up here, go to Annotation. I think it's really important for us to label and keep good documentation of what we are imaging for our own records. And this is just a very simple tool, but if you go right in here, you can put what it is, the date of it, and then you can put just anything that you want just to make it your own. I don't care if you're imaging with a cell phone, a DSLR, hundreds, thousands, tens of thousands of dollars of imaging equipment. Be proud of the work that you do. Post it online, share it with friends and family, and sign your name to it, because it's an incredible thing that we're able to do. I hope you found this video helpful on some of the advanced features that I enjoy using in PixInsight. If there's anything that you use in this program that you think would be beneficial for others, please be sure to let us know what that is in the comments section below, and any questions that you may have about how to use this incredible piece of software. Thank you all so much for your continued support, and clear skies from Late Night Astronomy.